Hello there. In today's video, we're going to go through skill 56. Remember, we have a pink packet you picked up for skill 55, and that's going to carry through all the way to skill 59. So skill 56 starts with question number 11. It says the probability that Gary and Jane have a child with blue eyes is 0.25, and the probability they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125. Given this information, the event blue eyes and blonde hair are, so we have to decide if having blue eyes and blonde hair is dependent, independent, mutually exclusive, or some combination of all of them. Mutually exclusive means that it can't possibly be both. And that's not true here because it says there's a probability that it's possible, and I'm sure we all know someone with blue eyes and blonde hair. So we're not going to pick any choices that have a 3, so now we're between A and B. So to check to see if two events are independent, you can use the probability rule that we have on the back of our packet that we wrote down. If two probabilities are independent, I can multiply them, and I should get the probability of both of them happening. And when I multiply these two probabilities, I do indeed get 0.125, so these two are indeed independent. Number 12, in a group of 40 people, 20 have brown hair, 22 have blue eyes, and 15 have both brown hair and blue eyes. How many people have neither brown hair nor blue eyes? So as soon as I read this question, I picture making a table, kind of like in question number 13 here, that puts the groups into rows and columns. So our possibilities here in number 12 is they have blue eyes or they don't. They have brown hair or they don't. And then I just put in the information. There's 40 people in this survey, so 40 is this number. Remember, whenever we do one of these tables, we want to have a total column and a total row. 20 people have brown hair, so that means that both of these have to add up to 20, so that's why I put the 20 right there. 22 have blue eyes, so both of these numbers have to add up to 22, so that's why I put the 22 down there. And 15 have both brown hair and blue eyes. That's this number here. Once I fill in this number here, I know this is 7, and I know this is 5. And since I know that the number of people surveyed is 40, I know that these two have to add up to 40, and these two have to add up to 40. So once we start to fill in all the spots, now we just have to answer the question. How many people have neither brown hair nor blue eyes? The answer is B, 13. And I got that by adding and subtracting to get that spot there. Number 13, the table below shows the food preferences of sports fans whose favorite sport is football or baseball. The probability that a fan prefers pizza given that a fan prefers football is, whenever you see the word given, you should stop and circle the row or column they're talking about. We're going to ignore the rest of this table and only focus on the given stuff, which is given football. So that means we're only going to pay attention to this row. And I even told it up. We found out there were 40 people that preferred football. And now let's answer the question. How many of those people that I circled prefer pizza? Remember, I don't want to talk to everyone in the survey. I only want to talk to the football people. So pizza's right there, 20 out of 40, which is a half. Number 14 gives you a Venn diagram about Algebra 2 students and sophomores. Remember, the number in the middle is people that are sophomores in Algebra 2. In this spot, it's people that are Algebra 2 students that are not sophomores. And right here, these are sophomores that are not in Algebra 2. And right here, this is kids that are not in Algebra 2 and not sophomores. It says, if a student from the high school is selected at random, what is the probability that the student is a sophomore given that the student is enrolled in Algebra 2? Whenever you see the word given, stop what you're doing and only focus on those people. So we're only focusing on the Algebra 2 kids here. Pay no attention to everyone else in this survey. The given is this survey, is this circle, and that is our denominator. So there's 295 people in Algebra 2. And out of those 295 people, how many of them are sophomores? 85 out of 295. So the answer is B. All right, number 15, the probability of having math homework is 1/3, and the probability of having English homework is 1/7. Probability of having math homework or having English homework is 9/21. What is the probability of having math homework and having English homework? So to do this question, we need to know this formula, which is on the back of our packet. Remember, this isn't something that's given to you. You just have to know that it's a true fact. So the probability of one thing or another thing happening, remember this is a symbol for or, probability of one or the other happening is the probability of one of them happening plus the probability of both of them happening minus the probability of them both happening at the same time. This is because we don't want to count things twice. So picture a Venn diagram, you don't want to count the middle section twice because it's in two circles, right? So remember the symbol means and. So I fill in what we knew. This is or, so the probability of A or B happening was 9/21. The probability of just A happening, which in this case I assigned to be math, was 1/3. Probability of English homework was 1/7. I need to add these two and then subtract the probability of both of them happening, which is what we're looking for. So I just made that x. So these combine to be 10/21. And when I subtract and solve for x, I get 1/21. And think about it. We have math homework about 1 every 3 days and English homework like once every week. So the probability of them both happening on the same day is not very good. It's 1 in every 21 days. Number 16, here we have a table here measuring males and females and right-handed and left-handedness. What is the probability that a randomly selected person is male given that the person is left-handed? So let's only look at the left-handed column. Ignore all the righties and only focus on the lefties. Remember, you usually want to make a total row or column in your table, especially for the column we're paying attention to. So our denominator is 24 here because there's only 24 lefties in the survey. And then what's the probability they're male? Well, there's 13/24. Number 17, Mr. Zachary posts review assignments on the Beta Math website for his students. On his last test, 49% of his students used Beta Math and passed. Overall, 68% of the students used Beta Math. Approximately what percentage of Mr. Zachary's students passed given that they used Beta Math? So I tried to make a table for this. Our choices are they did use Beta Math or they didn't. And they did pass or they didn't. And then I filled in the information. 49% of his students used Beta Math and passed. That's this box right here. 68% of his students used Beta Math. That's both of these numbers. They have to add up to 68. And once I knew that, then I knew that 19% of them that used Beta Math did not pass. Approximately what percentage of his students passed given that they use Beta Math? So we're going to ignore this row entirely. We're going to only focus on the Beta Math row, which means our denominator is 68%. And out of those 68%, what percentage of them pass given that they use Beta Math? 49% of them pass out of the 68%. So when you divide that, you get 72%. Number 18. In a survey, who recently bought a laptop, 45% said they were looking for a large screen, 31% they were looking for a fast processor, and 58% said they wanted a large screen or a fast processor. If the survey respondent is selected at random, what's the probability that someone said they wanted both a large screen and a fast processor? It's the same formula as above. It's the probability of one or the other happening, and it's equal to one happening plus the other happening minus the probability of both of them happening at the same time. And just like the last one, we're looking for that and probability. So I knew this was 58%. I knew that this was 45. I knew this was 31. When I solved for x here, we got 18%. So that was the last question in Skill 56. Thanks for watching.